Okay, so here is the Target 7C retake video. So for this particular problem, we have to find the values of x, y, and z. So looking at it, looks like x, y, and z are all angles inside this quadrilateral. So we have to decide what quadrilateral this is. And let's see, we have two pairs of opposite sides are parallel, so this is a parallelogram. Okay, so one of the things we know about a parallelogram is that all the that opposite angles in a parallelogram are equal. Okay, so I know since this is 111, I know that this has to be 111 too. So I know that Z is 111. They are opposite angles, and opposite angles are equal. Now, finding y is pretty easy, actually. This shape right here, I'm highlighting it right here, is a triangle, and we know all the angles in a triangle have to add up to 180. So y is the missing angle of a triangle. So I can add the 111 and 121, not 121, 111 and 21, and I get 132. And if I do 180 minus 132, I'll get the missing angle. So that's 7, 10, 8, 4, so 48. So I believe that y is 48. And you know, it's always good to check, so I'm going to just grab my calculator and make sure that I didn't do any of my math incorrect. 111 plus 121, sorry, 111 plus 21 is definitely 132, and 180 minus 132 is 48. So 48 is correct. Okay, so we know y is 48. Now there's a couple of different ways of getting x. One way that you might be considering is that if this is 111, then this whole big angle here has to add up to 180 with 111, right? So that looks like it's 69, I think. These two angles together should be 69, so then I think I could do 69 minus 1 minus 48 is one way to do it. So let's just go ahead and do it. If these two angles have to add up to 180, I can say 180 minus 111, 9, and yeah, 69. So that means that x and y together have to equal 69. And 69 minus 48 is 21. So I get x is 21. And that might be the way that you think to do it, and that works fine. But again, there's another method. There's usually always more than one method, so I do want to talk about another method that we could have used. These are parallel lines, right? This is a parallel line, and this is a parallel line, and this is a transversal. So look, 21 and x are inside the two parallel lines, so they're interior, and they're on opposite sides of this line. So they're alternate interior angles, and when the lines are parallel, alternate interior angles are equal. So that's the other way you could have looked at it, is using alternate interior angles. But again, whichever method you choose will work out fine. Alright, for this problem, LMNO is a parallelogram, and it gives us some stuff. So the thing is, I don't know where those sides are unless I have a picture, and they weren't nice enough to provide me with a picture, so I have to draw my own. So I'm going to start by just drawing a parallelogram. Whoa. Okay, now it doesn't matter where I start. I can start anywhere. Okay, what matters is that once I start, I either go clockwise or counterclockwise, and I go in order. So I write down L, the next letter I have to write down is M. I can't go L, N, M, O. I have to say L, M, N, O. So I'm just going to start here. That's L, and I'm going to go clockwise. So after L is M, and after M is N, and then O. So I went in order L, M, N, O. L, M, N, O. So now I have a picture, and I know that N-O-N is x plus 36, and LM is 6x plus 11. And I have to find x. Well, these are opposite sides, so I'm going to set them equal to each other. I'm going to say, since these are opposite sides, I know in a parallelogram, opposite sides, this is a parallelogram, are equal. So I'm going to say 6x plus 11 has to equal x plus 36. So I'm going to subtract x, and I get 5x plus 11 equals 36. And then I'm going to add 11, or sorry, subtract 11. And I get 5x equals 25. So 5x equals 25. Now I'm going to divide both sides by 5. And I get x is 5. And let me just double check that. So to check it, I'm just plugging in 6 times 5 is 30. 30 plus 11 is 41. And then 5 plus 36 is also 41, so that's correct. X is 5. Now I have to find the value of NM and OL, which I just actually found when I was checking. So if I had written it down, I'd already be done, but let me go ahead and change colors and we'll show you that. So we'll start with finding NM first. So NM, oh no, this is wrong. This shouldn't say the value of NM and OL. It should say LM and ON. LM and ON. So you need to switch that. And I think that could be a problem on the other slide too. So we'll have to take a look at that in a second. Alright. In fact, I'm going to take a look at it right now. So let me pause. Okay, so I did check, and the you try slide is wrong, so I fixed it. Alright. So NM, we're finding LM and ON, not NM. So LM is 6 times x plus 11. But we know that x is 5. So 6 times 5 is 30, plus 11 is 41. And then ON is x plus 36, but x is 5, so 5 plus 36 is 41. And that's a way to check, right? Like I said, LM and ON have to be equal, and they're both 41. They're equal, so I did it well. Okay. Number 3. Oh, that was 3. That was 2 and 3, and here's 4. So we're given the ABCD as a parallelogram, and I'm given the AE, so this little bit right here, AE, is 17. Okay, and I'm also given that this whole thing right here, BD, is 28. So we have a theorem that says that the diagonals bisect each other. So that means they cut each other into 2 equal pieces. So that means that this piece is going to equal this piece, and BE is going to equal ED. Okay? So then we're going to find all this stuff. So I know the AE is 17. So that means AE is this piece, so it has to equal this piece, EC. So that's 17. So I know that EC is 17, or CE, and it's because the diagonals bisect each other. So that means the two pieces are equal. Okay, now it also wants AC. So AC is the whole thing. AC is from here all the way to here. So it looks like it's 17 plus 17, right? So AC is 17 plus 17, which is 34. And it's 34, and why is because I added the two parts of the diagonals together. So it's the sum of the two halves of the diagonal. Okay, or you could say you added 17 and 17 together, just some reason. 17 and 17 is 34. Okay, now it wants DE. Okay, well, I don't know what DE or EB is, but I know that the whole thing is 28. And remember, it got bisected, which means it got cut into two equal pieces. So if I do 28 divided by 2, I get 14. So I know that each of these are 14. So I know that DE is 14 and EB is 14. And again, the reason is the diagonals bisect each other. Or cut each other into two equal pieces. And I could say the same thing for this one. And again, I did the 28 divided by 2 for my work. Okay? So next, we have to draw this isosceles trapezoid ABCD. Okay, now this time I have to be careful. So let's start by drawing an isosceles trapezoid. So remember, an isosceles trapezoid is a trapezoid where the two legs are equal. Okay, so these two legs are equal, and it's a trapezoid. So those are the bases, or the two parallel sides. And it says that AB, so here's AB, is parallel to CD. So I have to name it this way. AB is parallel to CD. So I have to name it this way. AB parallel to CD. Which means this really should have been called ABDC instead of ABCD. But it's not that big of a deal. AB and CD are parallel, so I have to make those two parallel. Now it tells me that angle C is 100. Okay? So when I look at this, here's angle C right here, and that's 100. But the problem with that is 100 is actually an obtuse angle, and this right here is an acute angle. So I'm not going to be that picky, but that actually tells me that I labeled this wrong. It's saying that C should actually be the 100. So C, D, and AB. Oh, I did that wrong. I just labeled it the same way I did before. Sorry. So C has to be 100. So I'm going to move this 100 up here to where it's obtuse. And I'm going to say this is C, this is D, and this is A, and this is B. Now again, if you kept the 100 here, all the other answers are going to work out okay. It's really not that big of a deal. I'm not going to be marking that wrong, but it's something that you should rethink. Okay, so since I first called this C and I put in the 100 here, it was clear that C could not be 100 degrees because it was acute. I switched it. Okay, so we're going to label the measures of all the other interior angles. So that means I have to find A, B, and D. So angle A is going to equal, well, remember, since these two sides are parallel, it turns out that these two angles have to add up to 180. So if that's 100, this has to be 80, because 180 minus 100 is 80. So this is 80. And base angles are equal, so B is 80. And base angles are equal, so D is 100. So A is 80. B is 80. And D is 100. Okay, and then using your drawing from 13, I know that AC is 3y plus 2. Let me grab another color. So this is 3y plus 2. And this is 5y minus 20. And I made a mistake here. This is not plus 2. It's actually minus 2. 3y minus 2. So these two are equal. 3y minus 2 is equal to 5y minus 20. So I'm going to find y. And I get subtract 3y. And I get negative 2 equals 2y minus 20. I'll write that over here. Negative 2 equals 2y minus 20. And then I can add 20. And I get 18 equals 2y, divide by 2, and I get y is 9. Then I have to find the length, so AC is 3 times y, but remember y was 9, minus 2, so that's 27 minus 2, which is 25. So this side is 25. And then BD is 5 times 9. Minus 20. So that's 45 minus 20, which is 25. So this is also 25. Okay, so I drew the picture and I labeled it. Okay. So remember, try to be careful on your drawing, but again, if I had called this 100 and this C right here, everything would have worked out okay still. It wouldn't be any different. So do try to make your, if it's an obtuse angle, put it in the obtuse spot. If it's an acute angle, put it in the acute spot. But it's no big deal if you mess it up. You should get the same answer anyway. You will get the same answer anyway. Okay, so number 7, we have a kite. And we have to find the missing angles of the kite. So angle 1, 2, and 3. Okay. So I think 2 is the easiest. We have a theorem that says that the diagonals make the diagonals of a kite are perpendicular. So that means they make 4 90-degree angles. So all 4 of these angles here are 90 degrees. So I know the angle 2 is 90, and it's because the diagonals are perpendicular. Okay, and that helps us with angle 3, because, let me grab another color. This shape right here is a triangle, and I know one angle is 33, the other angle is 90. So if I add 90 plus 33, I get 123. And 180 minus 123, and I get 57. So I know that angle 3 is 57. And the reason I know that angle 3 is 57 is because I did the triangle sum is 180. So I'm going to say that triangle sum is 180. Now there are other ways of getting it, but that's the one I went with. I said this is a triangle, I added these up, the triangle sum is 180, so I take 180 minus 123 and I get the 57. Okay, so there's a whole bunch of ways finding number 1, angle 1. Okay, angle 1 is actually just 33. And this isn't a theorem that we write down or anything, but if you look at these triangles, let me pick another color. I think I'll pick a highlighter and show you with the highlighter. Look at this triangle here. And let me get another color. I'll do this light blue here. Okay, I'm saying the yellow triangle and the blue triangle are congruent. And the reason that they're congruent is we have a pair of equal sides right here, see the marks right here, and another pair of equal sides right here, and then they share this middle side, right? That's the shared side. So the triangles are congruent by side, side, side. So since the triangles are congruent by side, 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 it turns out by CPCTC that corresponding parts of congruent triangles are equal. So if this angle is 33, this angle has to be 33. So it's because triangle ADC is congruent to triangle ABC. So angle 33 is equal to angle 1. Okay. Or you could just say the triangles are congruent and then CPCTC, something like that, okay? But that's really why. Okay, I could have done it another way, but this way I think is the most straightforward. All right, now number 8. Describe and correct the error in using the properties of the parallelogram. So this is telling you that there's a mistake. You have to figure out what the mistake is. So we're given that OM is 23. So I'm given that this right here is 23. Okay? So, and then it says, because quadrilateral ONML is a parallelogram, OM is congruent to NL. So we're saying that this line right here, ON, this blue line, is equal to LN, or NL, this red line. And that's not true. Okay, the diagonals are equal in one special type of parallelogram, but it has to be a parallelogram that is also a rectangle. So the diagonals are only equal if the parallelogram is a rectangle. And this is not a rectangle. These are not 90-degree angles here, and it doesn't tell us anywhere that they are 90-degree angles, so we can't say they are. So it's not a rectangle. So that means the diagonals are not equal. So NL is not 23. We don't know how long NL is. But it's not true because the diagonals are only equal if the parallelogram is a rectangle. Okay, and here your U-tries are. So remember, again, you have to show the following U-try problems to your teacher, and then you can do the retake. So your teacher, a math lab teacher, or a support teacher. Okay. So here we go. Here's the first one. You're given 23 and 118. You have to find x, y, and z. Okay, the second one, you're given this parallelogram. You've got to draw the parallelogram. And again, I fix that. You're supposed to find LM and ON, not NM and OL. Okay. And for number 4, you're given this parallelogram. You have to find all this information. For number 5, you have to draw an isosceles trapezoid. This is an acute angle, so you want to make sure that C is an acute angle when you draw the picture. And then 6 is the same drawing as number 5. And then 7, we have a kite. And 8 is another error analysis problem. Alright, good luck.